In this video, I build the most useless vehicle ever. It doesn't carry people, it doesn't carry cargo. It handles badly, it brakes badly. If you try to go fast, the drivetrain will explode. If you try to go slow, it'll load up and follow plugs. Gets bad mileage. It'll probably fall apart, but it's awesome. Now, before I get too far ahead of myself, let me show you what happened and how we got to this point right here. Because when you last saw this buggy in the last video, it didn't look like this. It had been sitting for over 30 years, no motor. I didn't even know what it was, I just knew it was cool. Now, I didn't even know where to start with this thing. So I figured I'd start with the easiest thing first. The whole brake system was complete, everything looked fine. So I was going to check the fluid and make sure the brakes worked. And that started it all. Come on, there we go, I see it turning. Let's see what's in here. And, oh, chunks of rust. Yeah, not very promising. I'm thinking rebuild time on that one. And probably this one too. Got the master cylinder out. Let's see how bad. Yeah, hopefully it works. Now I'm looking at this double cross member here. I noticed it's only attached on one side. I don't know if anyone ever really used this. I wonder if they tried to mock it up and realized that the transmission was way too close to the rear axle. So, see how hard this is to remove. I don't want to use this. Oh yeah, that came off way too easy. I also noticed these tires rub the body right here. And that happened a while ago, but I know for sure they're going to do it again. Which is a good thing, because I actually thought I was going to have to prep this body and paint it properly. But since I know it's going to get ruined anyway, we're going rattle can. I'm going to paint the frame first, and then the body, because I think it'll be easier to mask off the frames. Professional masking. We got a little bit of unboxing to do. There are a lot of aluminum radiators out there, and there are a wide range of prices, from under $100 to over $2,000. I usually start with the lowest price one and just scroll up until I see something that catches my eye. One good thing about the aluminum radiators on eBay is they usually have sizes listed right on the, basically a picture of it with dimensions, so you can see what it fits. It's actually better than a lot of regular auto parts stores because they don't usually tell you what size it is. They just say it fits whatever the application is. Luckily, the eBay ones often don't even fit the application that they say they fit. So by having the dimensions, you know whether or not you can make it work. So, this one right here, I forget what it's for. It's for like, I think it was a late 50s Chevy truck with a small block V8. Which should fit the inlet and outlet I need anyway. And basically it looked about right. Looked to make the sizes about right. It had the right shape, at least in the pictures. Let's see if it does in real life. And it was $145 plus tax. So that's pretty good for an all aluminum radiator. The flat flanges match the factory mounts real nicely. There's just a little bit of room on either side on the core, so it fits pretty well. I'm going to end up trimming off these, but I expected that. And these came in, these are completely blank flanges, so I can drill anywhere I want and it'll look like that's the only place it was been drilled, because it's the only place it's been drilled. Now, the other thing I was looking for is the tank that matched the shape, kind of. Let's see if you can line it up. See the body, how it curves like that? The tank has pretty much a matching curve. The same kind of up, over, down with a radius on either side. Got the same thing in the tank. So I actually could put a hood on this that is about that shape, and it'll match the top of the radiator pretty nicely. So that's maybe an eventual goal here. If nothing else, it sort of ties the whole two things together and looks like it was meant to be there. This whole center outlet and the inlet on the passenger side, that'll fit either a Dodge or Chevy small block. So right now I'm thinking Dodge small block because I have one. I think that looks like the radiator that should be there. It's time to test fit a motor in this thing. Technically, the motor is in the car. This is where I'm at this. I've got a motor and a transmission in it. I doubt this is the final motor that's going in it. I'm not sure about the transmission either. That's the 318, it'll run, but it's fuel injected, and I might have a better use for a fuel injected motor than in here, because fuel injection is not pretty to look at. At least not stock ones. Now the transmission. The transmission is another issue. We've got an NV3500 in here. This is a four-wheel drive version, which might be a problem because, you know, there should be a transfer case there to connect it to the rear axle. The problem is that distance. I have another NV3500 that is a two-wheel drive with the proper tail shaft. In my parts shed here, I have got an NV3500 in the two-wheel drive flavor. 33 inches. Roughly 33, 34. Keep that in mind. All right, measuring from the same spot, we have, there's 33, there's the rear end. So we have basically another 10 inches to go. That means my drive shaft would be going to about 40. We'd have about 7 inches of drive shaft there. That is not enough. I'm wondering if I can somehow add an output yoke to drive a drive shaft instead of a transfer case from here, because that is an acceptable distance for a drive shaft, especially on something that's not long travel. I've got a little over a foot here, so I think that'll be okay. But I don't know if I can get a drive shaft to hook up to this easily without a whole bunch of machining. Alright, now on these front brakes, I've never had them off. I know they've been sitting for at least 30 years. They're probably rusty. I don't know if the bearings are any good. I'd expect not. So I really need to take this drum off, check the bearings, check the brakes, and make sure everything's safe. So what I'm going to do... Done. They're perfect. That first side, I didn't see any obvious problems, so I didn't really feel a need to go into it. This one, there's something seriously wrong with that, and that could damage components if I ran it as is. And I am inherently lazy, so I know this is going to make me more work in the long run if I don't do something about this. So unfortunately, I need to do the work up front and do something about this massive, massive amount of wobbling. Hopefully I can just tighten the bearings up and be done with it. Let's find out. Huh. That grease doesn't look ancient. That is very loose. Huh. Well, it's full of dirt. Spider webs, of course. Brake shoes are shot. But the grease is there, and it doesn't look chunky or crusty. So we're done. Let's just tighten this back up. This means the grease seal is probably shot. Because it runs loose like that, it flops around, and that wears out the seal really fast. I'm probably going to end up getting grease going onto those brake pads, but they're shot anyway, so, you know, no problem. There. No more slop. Rolls smooth. I've got tired of masking rims. Boom. Masking's done. I can just spray it. This rear suspension arm is only attached with this tab. That tab is only on one side. You go in here, and yeah, it's not connected to the chassis at all. So that's in single shear. That allows this whole thing to flex. Only one tab on that outside is holding the entire rear end from sliding back and forth. Now I dug into my scrap bin, found a good thick piece of metal, and it's already painted black, so half the work's done. We're just gonna cut some brackets out of this. cracking. When I plasma cut out parts like this, I know I'm not going to get a perfect edge. So if I have any critical features like this hole that I want to be precise, I'll actually make them too small and then take a drill bit and pop them through, and that way the drill bit enlarges them just enough. The small hole will locate it, the drill bit gets the size right. I'm going to weld these brace plates on the inside of that suspension mount so it's actually in double shear. Now you may have noticed I cut a hole in the middle of them, which it's nice for weight reduction because it does do that, but that's not the reason I did it. The main reason is I want to weld on the inside of this frame rail here. I can't see it. If I can have a hole here, I can actually put the MIG gun around and see where I'm welding and actually get a decent bead in there. If that was flat, I wouldn't have been able to see it and wouldn't have had to sort of guess at it. So that's mainly for visibility, not weight reduction. That's a nice bonus. I really want to thank you guys for helping me ID the parts in this thing. Because of that, I knew this was a 51 Ford rear end, and then I could look up stuff on eBay. Got myself a slightly broken lens. There's only one crack in it, $6. And then I went and splurged. I got an original V8 emblem, some slight pitting for the 51 Ford. So I think that's going to go right there, something like that. But this is going to help out a lot, and I really actually had no idea. I wouldn't have found that without you guys, so thanks. Also, the pedals. On these pedals, you guys correctly identified that one as a late 50s Ford. Also very helpful, because I was able to get a matching gas pedal, brand new reproduction one with a hinge, that's going to match. Still need to find a pad for the brake one. They're available, but wow, they're expensive. So I'm going to try to find a used one that's worn out. I am just going to rattle can this thing, and for people who worry about, oh, you're going to have to strip it down to metal in order to fix it, you have to strip it down to metal anyway to get rid of the trunk paint. So I'm not making it any worse. I'm just going to make it look better for now, and eventually maybe I'll paint it right. I don't know. Probably not. I think a rattle can will be fine. The next owner can paint it right. So I'm going to strip off everything I can that unbolts and then scuff it and shoot it. That's a little bit of dirt buildup in that taillight. I'm starting to prep this buggy for paint. I knew it was kind of rough, but this is kind of next level rough. I mean, I've done some sketchy body work, but this is pretty bad. Right there on the floor, all that is Bondo just from this section. This is all filled in with Bondo. There's just basically Bondo everywhere. Every surface is coated in Bondo. Hopefully you can see this on the camera, but you can see how thick. That's like over an 1/8 inch thick of Bondo. You can see the gap where it's actually coming away from the metal. So this whole section of the body is going to just fall off at some point in the future. Looks like these whole surrounds around the taillights are all Bondo. This is just, well, Bondo. Yeah, I'm sort of redundant here, but Bondo, 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 Bondo. Pretty much Bondo. After about a half hour of prep work, I decided it really wasn't worth doing anything more to this. So I need to paint with texture. I'm going to go with some hammered black, because I like the way that hammered copper looked on those J10 rims. We're going to see if the texture on this stuff will cover up all the massive amount of Bondo cracking. And worst case scenario, I have to sand it down to metal and do it right, but yeah, that's not happening. We'll see what this does. I've got this buggy up on the lift because I've got to deal with that transmission issue. There's a number of problems. First, you probably can see it. That thing hangs way too low. The problem with this transmission, and the reason it hangs so low, is this cross member right here. This looks like it was actually meant for a transmission that mounted from the top and hung down, and it probably was a much smaller unit, probably an old 3-speed, maybe a 4-speed, but a much smaller casing. So I've got to deal with that. Really, there's only one solution. I've got to cut this cross member. There we go. At this point, I'm hitting the firewall. So let's get next to it and see if this looks plausible. It does still look low, but it's got almost a foot of ground clearance. I actually measured it because it looks so low. Apparently it's just the frame rails are really high. That's 18 inches off the ground. So I think I'm going to be okay here. And also I don't want to get any more severe in my drive shaft angles. Now the next problem I have is this transmission. This was actually meant for a four-wheel drive. As you can see, it's got a transfer case mount, had a spline piece go over it, actually. Had this spline piece, which slides in, and that's what drives the transfer case. Now, I was thinking of trying to adapt a drive shaft to this, which could work. Then I was thinking, just maybe, there is something that uses an output like this and actually goes to a drive shaft like a regular yoke. This is why it's good to work up a good relationship with people you know that handle a lot of junk, if you're ever expecting to do this kind of thing on the cheap. Because my buddy, who I trade parts with here and there, and I hand him off scrap metal and spare parts a lot of the time, I gave him a ring and I said, I'm looking for a 23 spline output yoke, and it's probably off an NP 435 transmission, which I knew he had some, and that was the only info I could find online, is some of them had the 23 spline. But he goes and yanks off all the ones off all the NP 435s he has, which was 2 of them, but still, he yanked them both off. These were too big. The spline count is 27 on these, so that didn't work. However, he also saw in his transmission pile a 4530 transmission that was off of a, if I remember correctly, a 353 Detroit diesel. He almost thought it was like the same thing as a 435, just the numbers mixed up. Anyway, that had this yoke on it. And this yoke fits. That fits perfect. So, if you want to use a four-wheel drive transmission, there are splined yokes that do fit the 23 spline output. I don't know how to source them or what application they came from, but they exist. Now there are some other considerations here. I can obviously put this spline on there. It fits, it'll drive, but it's not retained in any way. The whole thing, I could sort of make it like a slip yoke if I wanted, so it actually slid on these splines and plunged when the rear axle moved. That's a possibility. The other thing that you have to watch out for is there's a seal in here, so it keeps the oil from coming out, so oil stays in the transmission, but it's meant to have a bearing supporting it from the transfer case. So I don't think that'll hold up if I let it just go floppy around there. So I need to add some kind of bearing on the back here to locate it. Of course, I pop on eBay, because all sorts of used industrial supplies are available there. And I got myself a 1 9/16 inch bearing. And that's just the diameter of that oil seal on this yoke. This is a big old flange bearing, quite big actually. The inside part fits fine, but this actually doesn't fit inside the housing where I need it to be in order to actually get the splines to engage properly. So I need to make this square peg fit in that round hole. Let's see how easy it is to pop this bearing out. That easy. You notice there's 2 notches in this housing. All you do is turn the bearing to align to those notches. You're good to go. Now I got to square up the surface and bring it down a little bit so I get a better bite on the chuck on the lathe. I want to make sure this doesn't go flying out while I machine it. So we're just going to do a skim cut here of who knows what height and who cares. I think I'm pushing this lathe a little bit. Come on, you can do it. There we go. Got my bearing retainer roughed out here. Basically got the diameter set, smoothed off the back, and put a little notch on the front. I've got my bearing retainer. I've got my drive shaft yoke. Now basically what I need to do is I need to retain this yoke in this bearing somehow in a way that prevents it from, you know, escaping. with the drive shaft at 6,000 RPM. So I need to hold this in. Now there's a lot of ways to do this. A lot of them are very good. I'm not going to do any of those. What I am going to do is I have some Loctite 641, which is bearing something to do with bearings. So I'm just going to stick this on there and hope it glues the two together, strong enough to handle drive shaft at speed. Because that sounds like a good plan. There's a grease fitting. I took it off when I machined it. I just popped it on to grease up the bearing, but that will not fit in that hole. So what I'm going to do is take out the grease fitting. I'm going to go put a little flush mount pipe plug in there. If you ever need this kind of stuff, the surplus center is great on it. It was only like a few cents, less than $1 for sure. I bought a whole bag of random plugs at the time. We've got our pipe plug flush in there, so we can put it in, no dirt will get in. It still is able to have grease installed in it. It's a real pain. You got to take it apart, change the fitting, grease it, change it back. But you can do maintenance on it if you want to. It's not like it won't happen. Well, it might not happen because I won't do it, but it could be done if I actually wanted to, which I don't. So we drop it in here, and we've got an output. I don't have full spline engagement, but I have about a 1/4 inch not engaged. Most of it is engaged. That's not perfect, but it will drive it. I'm not sure how much power it'll take, but then again, I'm not sure how much power any of this will take. I'll probably blow up something else, or I might blow up this. I have no idea, but that is enough to drive it. So pretty much all I have to do now is make sure this whole thing doesn't fall out, and then I can start making a drive shaft. Found a nice used piece of 1/4 inch thick plate that should work fine for replacing the transfer case and making the bearing retainer. I think this is left over from that coupe project, but looks perfect for this. Got my plate cut out, and this is going to bolt on the back here. And this right here is a learn from my mistake situation. Let me show you why. Got that plate in place with 5 bolts. This one, no chance of it fitting. It's way off. I made the assumption that this was actually a symmetric pattern. I didn't actually measure that. I just did 6 holes evenly spaced. That one's not evenly spaced. So don't assume that the pattern, even though it looks symmetric, isn't. This one's half a hole off and I can't install it. Now, another thing you may have noticed is I got a couple little ears here. I know this whole thing's gonna be sketchy as far as the drive shaft goes, so I'm gonna go ahead and build myself a scatter shield right here off the transmission. That way, when the U-joint lets go, not if, when the U-joint and yoke let go and go flying off somewhere, it's not going up that way towards me. So I'm gonna go ahead and weld some angle. I actually scaled these for 2x2 angle that can stick off, and I have some in this old cross member. So I'm gonna weld those in. And then I was thinking while I'm doing that, that's a nice sturdy spot mounted to the transmission. I'm gonna put my transmission mount right in that top section, hang the transmission down from a cross member up here. And that way, if I need to adjust my drive shaft angle or anything, I can raise or lower it real easy by putting in spacers or taking them out. And I can get the drive shaft angle set nice. And the other thing that'll give me is a lot more ground clearance. Now, if it becomes an issue of strength, I can always build a cross member afterwards once I get the position finalized. But this will get me to the point where I can actually test it and try it out. And who knows, maybe it'll stay that way. If it works, it'll stay that way. I'm gonna repurpose this cross member here. I bought this one years ago. It was made for a Jeep that popped up on Marketplace at a price I could not pass up. Even though I didn't actually have anything for it to fit in, I figured I'd use it someday. And I'm gonna dust it off, pop it in this thing, and see how it looks. Unfortunately, I don't think that seat's gonna cut it. Let me show you. It fits in a little too well. In order for the driver to be sitting in front of the steering wheel, the seat has to be pretty much shoved this way as much as possible. There's room for a whole other seat over there, which unfortunately means I gotta scrounge something else, and I can't think of anything offhand I have lying around. I think I'm running out of seats lying around, so I'm not sure what I'm doing there. Ooh, I just got an idea. using this car. It's got bucket seats. It has the right vintage. Oh, I like the chrome there. The white, I don't know about. Huh. How hard are these to unbolt? We may end up with Mercedes buckets in this thing. For some reason, the passenger door doesn't want to open from the inside or outside handle. The sliders don't work on the seat, and one of the bolts, the nut on the back side, is spinning around, so I can't actually undo it. So we're going to go from the back seat, use the right tool for the job. There we go. Yep, angle blade. Got my stolen seats in here, but they don't fit, of course. The big problem is this mount. It sits really low in the front and really high in the back, which angles the seat downward. So pretty much you slope into the steering wheel. I don't like that, and so I've got to fix it. Now I could cut and weld these. Problem is, I might need to put them back in the car I stole them out of. And what I'm going to try to do is unbolt them and flip them over so that they point backwards, so the riser's in the front and the small low part's in the back, and that way they tilt down. Now the problem that's going to give me is my seat adjuster is then going to be on the back. But at least it's still adjustable, and if I really need to adjust it, it's not going to be comfortable, but I can do it. So I'm going to give that a shot and see how it works. You ever smelled an old Mercedes? They have a distinct smell to them. Kind of like an old Volkswagen. I'm wondering if it's the kind of horsehair they use in their seats or what. But they always have a unique smell. And this seat smells like a Mercedes. Definitely smells German. There we go. Apparently, these tracks are reversible. That's handy. Now, lesson learned from Project Frogger. Sit in it before you finalize a position of anything. Make sure you fit. That was a problem before. Alright, actually this isn't half bad. The shift lever is jamming into my leg, so that's going to have to go. I can bend that later, once I figure out where the transmission goes. But yeah, I got enough room I can even slide the adjusters forward if needed. So yeah, this can work. Shift lever needs to go up 6 inches to the side, and we're good. Good enough for now. Now how do I get out of this thing? Yeah, definitely need something here. There's the ground. I think I'm stuck. Call my wife. I'm stuck in the car. Can't get out. There we go. So I found some side steps in my scrap metal pile. A little mangled, but we're adding some steps to this thing because I'm not doing that every time. My eyeball measuring on this seat shows me that it's that way of center, which means if I put another seat the same size here, they won't fit. So that can't work as a pair. But I'm going to ignore that because it's in there and I want to drive this thing. We'll figure this part out later. Now I need to mount this radiator somewhere. I'm going to be on the mounts, so the front and back position is fixed, but height I don't know about. Eventually I do want to put a hood over this, so I think what I'm going to do is make sure it works with the hood that isn't there yet. So I'm going to take this convenient broom handle, lay the broom handle where a hood would go, then eyeball the rake, and that's how I'm going to finalize my radiator position. I'm going to line it up with something that isn't even built yet and may never go there. Sounds like a good plan. After a little bit of fiddling, I think I got the radiator where I wanted it. One thing I've determined for sure is nothing in this car is square or straight. So it's a best guess. It's going to look a little different in the front than it does here. Nothing lines up. So I'm just going to go with it. Yeah, it's time for this thing to come down, take out that test motor. I want to open up that firewall a little too. And next I'm going to steal a good motor that's easy to hook up and plop it in this thing. Found my motor. I'll reinstall this next year, but it's time to race again. Kind of handy not having a floor. Maybe I shouldn't put one in. It's a lot easier to change motors this way. There's Celeste Dolphin. She is in there. I want to open this up a little bit so I can raise the transmission up. And I want to do it with a fairly even line. So what I've done is I took a Sharpie, added a piece of wire to it. That way, the wire can be my guide. And I can make an even mark all the way around. A little bit of tap magic helps. Oh. Broke the blade. That was my last one, but I think we're close enough. Oh yeah, I'll just sand that off. There. That looks better. Okay, we got to talk a little bit about belts. This motor uses the stock Serpentine belt system that came off the Grand Cherokee, Dakota, Ram of this era. And originally it had both a power steering pump and an AC pump. Now I actually deleted the AC compressor already, so I was just running the power steering pump in that Grand Cherokee. Now I don't need a power steering pump at all. So I got to delete that also and get a belt that runs all the accessories properly without two of them. Anything that has a V-groove on it is going to rotate one way, the same way as the crank pulley with a V-groove. Everything that is flat is going to rotate the opposite way, like the water pump. Idler pulleys, they could spin any direction, whether they have grooves or flat, basically is wherever they happen to be. Those aren't critical. Water pump is critical. Even the alternator, I'm pretty sure you can spin an alternator backwards. Haven't tried it, but I think they'll work either direction. I don't know. If anyone else knows, put it in a comment, because I'd like to know that. Might come in handy. So I've got to find a belt that fits this number of pulleys in a way that makes everything turn the way I want. This is actually pretty easy. Let me show you how it works. I lost my tape measure. All right, it's easy if you can remember where your tape measure is. Seriously. No idea. Oh, found my tape measure. Now I got two. All right. Now basically, you need to sort of get a rough idea of how this is going to work. Now, the pulleys, the power they transmit, you need to have a pretty good wrap of the belt wrapping around there in order for it to transmit power. The more wrap around there, the more surface area you have, generally it gives you a little better traction. So you want to make sure that you come up with the orientation that wraps around them pretty good. Now, the water pump is right below the crank pulley. You're going to go one way around the crank pulley, the other way around the water pump, and try to get it to go as far as you can. In this case, that pulley would be my furthest. So I'm going to go wrap around, come around here. The alternator, I'm just going to go right over top of. This isn't going to draw a whole lot of load. It probably wouldn't work if you're trying to run high power accessories. It'll probably slip, but I'm not, so it'll be okay. Then the tensioner, you got to keep in mind that temperature is spring loaded one way. You need to make sure the tensioner tensions it. So I'm going to go around the outside of that and right back down to the crank pulley. And now you can get a measure on your belt length. But this is the wrong length because you have to make sure you have that tensioner actually compressed before you get a real number. So what I usually do is get a minimum and a max, pick a belt somewhere in the middle. So we have 57 inches right here. Now I'm going to take the tensioner and swing that all the way over. Sometimes you need a few extra hands for this, but all right, we're around 55 inches there. So between 55 to 57, 56 is in the middle. Now, you go to buy a belt. You have a couple things to pay attention to. The number of grooves. These pulley have 7 grooves. You don't have to buy a 7-groove belt. You don't have to use all these grooves. The more grooves you have, the more power it'll transmit. But in this case, I'm not running the AC compressor. I'm not running the power steering. I don't need a whole lot of power. I could get away with using only 4 of these grooves, really. In this case, I went with a 6-rib belt, mainly because I had to do that before. Because a pulley misalignment kept jumping off one V, I just went with a 6-rib belt. It ran on one side on one set of pulleys, the other side on a different pulley. Everything worked out great. So, you basically have your number of grooves, you have your length. This is a 560K6 belt. It is 56 inches around, 6-rib. So, we got our belt. And those part numbers basically work the same way. You can add the number of inches, put the number of ribs behind it. They don't have every size, but you can find something that'll work. Now, with what I'm doing here, I'm actually putting a groove side on a flat pulley. That really won't locate it as well as the groove pulley would, but that's where I have to be. So I'm going to try it out. If the belt comes off, I can swap out this other pulley for a groove style one. But we're going to go with this for now. Boom. We now have every accessory driven in the correct direction, missing the 2 we don't want to drive, and it's all ready to go. I'm at the point where I need to mount this motor, and I ran into a problem I never thought about. Because I was going to make some motor mounts. These are the original ones out of that Jeep. I was going to basically take these, make a cross member, run some plates up to them, you know, basic simple stuff. So I mocked up a cross member to see where I needed to be. It's not square at all. This motor mount on this side is a different location than the one on the other side. Measuring from the bell housing surface over, we have 21¼ inches. Here on the other side of the motor, from the same bell housing location, we're at around 19¼ for that one. So that one is way offset. The whole cross member would have to go at a severe angle in order to work. These Magnum motors are kind of neat because they have 2 different sets of places to locate motor mounts. You've got the front tabs here. There's also a 3-bolt pattern right back here. You can use a side-mounted motor mount. Now, as soon as I found out that the 2 front mounts from the Grand Cherokee are completely off alignment, I figured I'll go to the other mounts and make a new set there. Because my transmission's mounted all the way on the back, so that has a lot of leverage. If I have the motor mounted at the front, basically there's a lot of stress in that interface area where the bell housing is. Remember, those are only bolted on the top half, not on the bottom. So I didn't really want to make that any worse. So I figure I will go with the middle motor mount. That way my motor's pretty balanced and the transmission is just going to keep it level. So I decided to go with those. I found out those are cast into the block off center too. Now this is a 3-bolt pattern, similar to like a Chevy style. I'm going to go to the middle bolt for this measurement. Now on this side, we have 10�¾ Same bell housing, going to the middle bolt again. That one is around 12⅛. So that one is way far forward of the other side. So the driver's side is forward as the passenger side on these castings. It's backwards of the passenger side on these front mounts. I thought I had a solution. These are the cheapest motor mounts I could find that would bolt to the middle set of motor mount bolts. And I noticed when I was looking at the pictures buying them, you have the 3-bolt pattern here, and then where it mounts is actually offset from the 3-bolt pattern. So I thought that was fantastic because that'll take care of the offset and put both mounts in about the same spot. Wrong. The offset makes it worse. That's where it bolts on. It actually takes this set that's too far forward, then moves it even further forward. Then you flip it around, on the other side, it's too far back on the mounting pads on the block. It moves this even further back. So these are completely wrong. Now, since these are already offset in the wrong direction, I'm going to flip them over. Obviously, the 3-hole pattern won't line up entirely, but 2 out of the 3 will. And that means I only need to make 1 more locating feature, and I'll have my 3-bolt mount again. So I think that's what I'm going to end up doing. At least I'm going to give it a shot. All right, now before I go any further, I'm going to make sure that's a distance that's about equal. That way when I make these mounts, I can make a straight cross member and just comes straight up from that. I don't need to make anything weird looking or complicated. And we're looking at 15 1/4. Let's see what the other side looks like. Let's see. Oh, look at that. 15 1/4. We are dead on. So by using these offset mounts exactly upside down where the factory had intended them to be, we actually have fixed the whole off-center mount problem. Now, I assume they did this for some kind of noise, vibration, harmonics thing, where being across directly from each other made the whole thing rattle, and offsetting them made it smoother. Which is all fine and dandy when you don't see under the hood, but in a motor like this, sitting out in the middle of everything, everyone is going to notice a weird, funky cross member. So I want mine to look pretty straight across. And now I have mounts that'll do it. Now I'm going to go and actually figure out a cross member. Now, cross members can be done in a wide variety of ways, pretty much anything you want. But there's a couple things we know. This frame is made out of C-channel. This frame is going to be flexible. If I just mount from one side out, it's going to be bendy. You can mount from one side if you've got a box section, works a lot better. But for C-channel, you don't want to do that. So I'm going to want something that goes all the way across and connects both sides so don't twist the frame. Also, I figure I want the cross member to do something useful, because there's no sense in putting something across and not have it provide another function. This is going to be an off-road vehicle, and there's a big old oil pan hanging down. So I'm going to actually try to build a skid plate to protect that oil pan into the cross member. Now, I've got my mounts here. Those are set up at a 45-degree angle because it's a 90-degree V8, so each side is 45. And I'm going to take a 90-degree angle, twist it this way, and connect to those motor mounts. Now I just did a simple piece of angle iron, one bolt hole through the motor mount. So I'm going to set these on top of that tubing, something like that on both sides, and that way it welds in pretty solidly and evenly. Also, that gets down and that'll get down and protect the oil pan there. I'm actually going to do 2 of those hoops, one for either side of the motor mount, because those bolts, the spacing in between is about 4 inches. So I'm going to do one by one on either side, then connect them in the middle with something that goes across the whole thing. So pretty much we'll have an engine cradle, then go to the frame. Here you can see the side view of what I did. I've got the hoop I did initially. I did another hoop with a slightly bigger angle so it goes up some. That way we get a slope down, and I can attach something to the bottom to protect that oil pan. And then a piece of 2x2 that goes all the way across to those frame rails. And I'm just going to run some bolts straight up into the frame rail on that. So it's tacked. I've got to fully weld it, and there it is after welding, the motor cradle and then the cross member. Now I'm going to let it cool, drill some mounting holes on the ends, and do a little coat of paint on it. What I've got here is a transmission with an actual output and a rear end with an input. Now the rear end uses this wing style U-bolt mount. The transmission uses this unknown U-joint type. I don't even know exactly what that yoke was used on, so I don't know what it fits. Because I hoard everything, I actually have a selection of drive shafts to choose from. Now, this drive shaft is from a '94 Dakota. This is a truck that I sold the transmission and transfer case out of to do my V8 ZJ 4x4 swap. But this happens to have just the right U-joint on the beginning of it. And this yoke is machined with a flat surface for an inside clip. And it just happens that they fit. So that is that end. Now, this also includes a slip yoke, which is good because I don't have one in the transmission, but I have to hook it to this rear end. Now this is where things get interesting. Now on this rear end, I did find a U-joint that fits it. I looked up a 48 Pontiac. Those caps fit perfect. So that's the U-joint I need. The problem is, these caps here are really small. This is what's known as a 2R series U-joint. It's a real small 1-inch cap. I cannot find a drive shaft to fit that. It was used in the 40s and the 50s, all the way up to the 60s Mustangs. But those drive shafts are getting hard to come by. I found none whatsoever in any junkyard I went to. I found one guy on Craigslist who was selling the U-joint, selling the drive shaft I needed with the right end, except he said he couldn't be bothered to waste his time finding it in order to sell it to me. So I was sort of stuck. So my plan was to take a sleeve, put a sleeve over these caps and then install them in something, trying to sort of make up the space between these small caps and a bigger one. Then, very strangely, the guy I bought this buggy from sent me a text saying, hey, I found the drive shaft. So now I have the original stubby drive shaft, and that fits perfect. So this will bolt on this end. Obviously it fits. This end is useless for me, but I have a saw and a welder. The front motor mount is in. The rear motor mount, I left adjustable to get my pinion angle right. It's time to set that. Now, basically, you want your transmission output and your rear end input to be basically on the same plane. They can be parallel to each other up and down, but you want them both pointing the same direction. Otherwise you get vibration, which I don't care that much about, but I might as well try to get it right. Now, one problem I'm running into is this buggy is not loaded. This suspension, the single trailing arm design, that arm is going to actually allow that rear end to change angle through the travel. So because there is no one in this and it's not finished, the weight's not the same as what it will be when I'm driving. So I need to simulate that weight. Now you can pile stuff in there and try to get the weight right, but that's a lot of stuff. I've got a hanging scale here. What I'm going to do is I'm going to use this hanging scale. I've got it tied to the vehicle. I'm going to put the bottom part on my lift. I'm going to pull downwards until the hanging scale shows me the amount of weight I need, and that should set the rear suspension. I'm going to shoot for around 300 pounds or so, assuming we're also going to add gas and a battery and a person. I think between 300 and 400 is a realistic number. So go ahead and get that set. So about 320 pounds of force pulling down. You probably saw the suspension move as I did it. So that means the rear end should be in the right spot, and I can actually measure my angles now. This pinion is now twisted down about 2 degrees, actually about 2.5 degrees from where it should be level with the transmission, which means I want to take that transmission and go up slightly on it so that I can get those parallel. Now I left that mount adjustable just so I could do this. So I can crank it up until I get the angle I want. Got my angle, I know where I want to be on the transmission. It's not perfect, but basically about as high as I can go until I hit the firewall. It puts me at a little less than 1 degree, like 0.9, which is close enough for now. If I want to get it perfect, and after I try it out, if the rear end still hasn't exploded, then what I'm going to do is make some spacers for that motor cross member and drop that down a little bit. It's just bolted straight up, so all I have to do is put a spacer, longer bolts, done. So that would be easy, but I think we're good enough for now to try it out. So now I'm working on a cross member for the transmission. Now I already welded one in to attach the seats. If you remember that plate I put in there earlier, I welded this right in the corner. So that actually braces the plate up quite a bit and strengthens this. On the front side of the plate, I'm going to put another one because I want to mount the transmission as close as possible to the transmission. Even though my little extension would actually go to this one, I don't really want to have a big lever arm. So I want to go as close as possible up here. So I took all that off just to facilitate getting this thing in there. And once I do, weld that in place, then I'll bolt that piece back on, bolt the transmission up with some kind of rubber mount. I got to double check my measurements, make sure my bolt hole is in the right spot side to side. Rear ends offset slightly to the passenger side. I made sure on the front I offset that mount slightly, the same amount. Make sure this is offset the same amount, and everything will be in a nice straight line. So I'll give it the best shot it has of not exploding. We're in the right spot, can burn that in, and then start bolting stuff together. Got the cross member welded in. Now it's time to make up a transmission mount. Now of course, I hoard old body mounts and transmission mounts too. So when digging through my pile of random stuff, and in that pile I found a set of nice bushings where they have a cup washer and then a rubber insert. So my plan is I'm going to use an insert on either side on this plate. So a top and bottom one. Put a sleeve through the middle so I can tighten down the bolt. It locks in solid, but yet that plate can float up and down on the rubber and have a little bit of motion on it. Now all I'm going to do is take this rubber bushing has a small hole. I'm just going to enlarge that to fit this so it passes through, and then just stack the whole thing together with a bolt. Yep, I think I can slide it through now. And there's the final stack. I actually have to crush the rubber about a 1/4 inch before this top plate actually hits that sleeve, but that's good, that'll squish it all together. And then this plate can actually freely move on that sleeve, so that can actually move around up and down because there's rubber on both sides. I've got my stub on there, got this one cut. What I did is I extended it, retracted it, found the middle, and shot for that for my length. So hopefully that works. So what I'm going to do is pop this in here and then see how everything looks. And it doesn't look good. This U-joint is apparently not meant to flex that far. That drive shaft is off a truck that had independent front suspension. So yeah, doesn't flex nearly as far. Basically this cap runs into the yoke. Doesn't flex nearly as far as a regular drive shaft does. This one moves pretty good. It's got a pretty good range of motion. This one has a very minimal range of motion. So, new problem. All right, let's figure out how to solve this. Okay, I got a plan now. I'm gonna solve a few problems all in one shot by changing everything. First off, the motor and transmission, I am gonna drop them down. And the problem I had when I bolted in that cross member was the motor is at this angle, the frame is at this angle. So they didn't quite meet right. To make up for it, I actually stacked some washers to make this have an angle to it. And I don't like that. So what I'm gonna do is I am gonna use this old piece of aluminum that I didn't use to make a carb spacer for that tug. And this happens to be saw cut at an angle. So that is going to be a spacer and an adapter that changes the angle and fixes that whole misalignment issue. So that's going to drop the front of the motor down a little over 1 inch. Now in the rear, on the transmission mount, I am also going to drop that down a little bit too, but not quite as much. Oh, that had a little bit too much angle down. So by dropping the front of the motor down 1 inch, dropping the rear down probably 3/4 of an inch or so, I helped the drive shaft angles. Then I found another drive shaft. Now, this one doesn't actually have the U-joint I need, but this one does. And it looks like the two U-joints are compatible. Also, you can see the angle here. Let's see, this one tips, well, just tips a little bit. It only goes that far an angle. This one goes way further. So this, if I put that U-joint in this drive shaft, I should be able to get a lot more angle out of it. Also, the other problem I had was this drive shaft. This one was really small diameter here. This is my stub, the other half. That was a lot of space. I'd have to come up with some way of adapting that. This one, on the other hand, is almost exactly the right diameter. I actually think this piece will slide inside that piece with a real nice fit. So that might solve my adapting problem. So I'm going to change the drive shaft, I'm going to change the front cross member, I'm going to change the transmission cross member, and then everything should be fine, I assume. Maybe. So that's my plan, and I'm going to start in on it tomorrow, because I'm done for the night. Found a pile of spacers in my parts bin. These are neat because you can actually undo the bolt and slide them in without taking it out. But I'd worry about them falling out under use. They're 3/16 thick. Got some 1/4 inch thick stuff. Got some 1/2 inch thick stuff. I think I'm going to go with 1/2 and 1/4. And I'll use the ones that go around the bolt so that way it can't fall out no matter what. So that should do it. And if we need to adjust it, we got more. Now, if you're working by yourself and you get into a situation like with these motor mounts, got my spacer here, the bolts wouldn't quite line up, ratchet straps are your friend. So now I can have this hold the alignment in place while I get that bolt in. I need a punch and a hammer to do it. Couldn't have gotten this without that ratchet strap. Now that the whole motor and transmission are dropped in at a new angle, I'm going to take a new measurement for the new drive shaft. So, still got my stub bolted here. I'm going to go from the edge of the cap. Really doesn't matter where you measure as long as it's the same spot every time. So I'm going to go with the outer edge here and then go. I want to get pretty close to where this tube is welded on the end here. So I'm going to go, let's see, there's the weld. 12 inches. That's going to get me pretty close to the cap, and worst case scenario I can trim it if I need to. So now we need 12 inches in our new drive shaft. Alright, now I'm going to do two measurements. Right now that's extended all the way, so we're going to go to 12 inches here. Then compress it all the way. We'll go to 12 inches there. So now I have a distance, and I need my drive shaft somewhere in the middle of that. This other drive shaft that had the slip yoke only had 2 inches or less of travel. This one's got a full 3 inches, so this is definitely a better choice. We'll cut it there. That way it can plunge in 1 3/4 of an inch, plunge out 1 1/4. Because I think if anything, it's going to be getting shorter. So hopefully that works. If not, I can always cut and weld again. Got it. That looks pretty decent. I'm going to go install this, the U-joint from the other drive shaft in this end, and see if we have something that works. U-joints are pretty cheap, so if you have a drive shaft apart, there's really no sense in reusing an old one and moving one from an old shaft to another. So I removed the old one and put it on a new shaft, and I'm just reusing it. Oh yeah, that goes down plenty. That means, gotta do that next. Now, if you've seen any of my videos before, you know that I'm not exactly showing you the right way to do things. Pretty much I cut corners, I do sketchy stuff, I drive things without brakes. You generally don't want to do anything that I'm doing, just learn from my mistakes. But this is going to be epically sketchy. So if you have any friends that are squeamish about this kind of stuff, tell them to leave the room right now, because you're not going to want to see this. I have my stub drive shaft, I trimmed it down. I have the other end, that's all going to fit nice, but it's all wobbly. Now, it's important to make sure drive shafts are straight, because any kind of wobble, if you welded them together, is probably going to make them fall off and go through your floorboards and, you know, kill you or blow up the world or something. But what I'm going to do is use a piece of exhaust tubing. Now, I'm going to slice this, it's the right wall thickness. It should make the appropriate shim between this one and that one. So I'm going to just slice this off, wrap it around, shove the things together, and weld it up as though none of that ever happened. And yeah, that should work fine, I assume. We'll find out. Got it mostly wrapped around. It distorted a bit when I cut it, so we're just going to straighten it out. There's the sound of solidity. Totally strong. I might actually trim this off. Let's see if it fits at all. Not really. Let's try fitting it the other way. You see that big gap there? That's going to throw off the balance. So, yeah, that'll be fine. Okay, yeah, definitely have to trim this off a little bit. It sticks out. So, let's shorten that, and we're gonna, yeah, we'll shorten it, and then we'll probably have to hammer this thing together. Before I do that, I'm actually gonna drill some holes in this shaft, because this is gonna be the outside one. I'm gonna drill some slightly smaller holes in this one, because this will be the middle, and I'm not gonna drill any in this one. So what's gonna happen is the outside sleeve will have the biggest holes, then a smaller one, I'll line them all up, and then I can weld straight through the outside one into this inner one. And that'll make it safe, right? Now, the other thing's important with drive shaft is the phasing. You want the U-joints to be lined up with each other. When they're at an angle, they go faster and slower. You need the other one to go faster and slower the same amount. So I got my holes drilled. The phasing might be right. We're going to shove these things together. Obviously, alignment's critical, so I'm going to eyeball it. I'm going to use this unswept floor to do a final check on my phasing. You can push down and sort of feel where they rock. I should have coat of paint on this because paint fixes everything, or at least covers it up. Oh yeah, looks like new now. Driveshaft's all painted up. Well, it's nice and pretty looking, so that means it's safe, right? No one needs to know that it's being held together by a piece of exhaust pipe. If you did have any friends that left the room, you can tell them it's safe to come back now. Everything will be fine. And I'm going to install this in the meantime. If you just returned, welcome back. Look, nice shiny drive shaft installed. There's no problems at all. It actually works real nicely, spins free. Everything looks good. We've got plenty of slip travel, both forward and backwards. So at this point, if we start up that motor, those rear wheels will drive. On this transmission, I bought it out of some guy's backyard, real cheap. It was already removed from the vehicle. And he definitely made a point of not saying that it worked. He was selling it for parts. Now come to find out, you can shift through the first 4 gears. You can't put it in 5th or reverse. I'm thinking it's something to do with the linkage or a slider, but effectively, this is a 4-speed transmission with no reverse right now. Also, it had been removed from the truck for a while, sitting in his yard, so I'm actually going to check the oil. Usually these are full of water, so I probably should drain it. Let's see what we got. Oh, that's actually oil. That's oil in the bottom too. There's no water in this? Kind of surprising. It's one of my few transmissions that don't have water in it. While I'm on a maintenance kick here, I'm going to check the rear end. Don't actually see a plug, but I see a pile of dirt here that looks like it could have a plug under it. So we're going to scrape that away. Yep, I think that might be the plug. There we go. There we go. All right, nothing's pouring out. Oh yeah, there's oil right there. So, yeah, we've got oil everywhere. Grease everywhere. It's like a new vehicle. Well, I took the less mangled of these 2 steps, and I'm going to try installing that. So I'm just going to have one for now, but that's the side I'm in, and I only have 1 seat, so perfect. Seems usable as is. She's out of the shop. I'm going to hook up the radiator now. I figured I'd wait till I was outside to do this because it's probably going to leak. Got to steal a few more parts off this race Jeep. This nice fuel system that's zip tied on here, I'm going to steal that. And then when it comes to racing, I'll redo this and probably even bolt it on. I'm stealing the ignition coil too. Now this is the one that failed on me while I was racing. Looks like it overheated. I found something interesting. It has all these cooling fins. Now keep in mind the motor's right here. The headers would have been right about here. Let me show you something I found on the motor. That is soot from the exhaust, which tells me 2 things. 1, it was running rich, and 2, there's an exhaust leak going right there. Right about where the coil was. So I think what happened is I was blowing hot exhaust directly on that coil. All these nice fins were actually heating up the coil with the exhaust. So I think I caused my own problem. But now I know, so we'll do something different this time. Well, now it's time for just all sorts of little odds and ends. I need a throttle linkage, I need a place to hook the return springs, I need do some wiring, some sort. Probably should bolt the seat down. Some kind of gas tank, obviously it's gonna be a boat tank I'm just throwing in, but I will need a pump too. So I'm gonna start knocking out all that little stuff. for sure I need some kind of clutch in this thing. Now the cylinder that was here, I took apart and there's absolutely nothing inside it. Here's the clutch cylinder. Now if you can see through it, there are no parts inside. No piston, nothing, which is odd. I'm thinking it actually rusted away while it was bolted here because the bolts actually were in so good they snapped. So it's not like someone took it off and stripped it. So anyway, can't use that. I do have a clutch master cylinder lying around, so I'm going to see if I can adapt this one in. The push rod length is about right. It's a little short, but not too much. I think it'll work. So we're just going to add a couple new holes, bolt this in, and then make up a line for it to fit. Got the clutch master cylinder mounted. This used a flare fitting. Had to go to a flare piece of tubing. Then I had to go a couple adapters to a pipe union, which I welded to a tab so I could bolt it to the firewall and hold it secure. Then to another adapter to a AN line I found cheap on Amazon. And that line goes down to the Mopar slave cylinder with another adapter. It's just held in by that little bitty roll pin there. And it appears I forgot to tighten this fitting, so it is now self-bleeding. So this should be already bled by the time I get done talking to you and try out the pedal. Is this the right bore size master cylinder for that slave cylinder? I have no idea. This was for a 80 something CJ7. The slave cylinder came off a 2000 something Ram 1500. I don't know if they're compatible, but I just hooked them up anyway. So we'll see if it works now. Figure it's got to do something. Now I couldn't get all the air out of this slave cylinder. Basically the problem is there's no bleeder. So what I'm going to do now is take this fitting, put it in the most vertical possible orientation, and then cycle the cylinder. And this is going to push the fluid and the air up into the master cylinder. And hopefully with this pointing vertical, I'll get the air trapped on both this and this end of the cylinder. Now that feels like a clutch pedal. Now it's time for the moment of truth. Will this buggy that hasn't had a motor for over 30 years be able to drive under its own power? Let's find out. Now on this car, the first thing I tried to get going was the brakes. And yeah, I still haven't done it yet. I actually let that cylinder soak in some evapo rust stuff, trying to get rid of the rust that was inside it. For most of the time I was working on this, I just pulled it out. And it probably is better, but it's still not good. Here's the old piston. There's the old cup. I assumed since this was chrome, it was some kind of specialty aftermarket thing. Then I decided to try looking for the same application as the pedals, the late 50s Ford truck. And someone in town got me one. 60 bucks, but it is a 59 Ford F100 master cylinder, brand new. And they are basically identical. So at some point, someone was selling chrome versions of a 59 Ford master cylinder. I like the chrome, but I like working better. So let's see if we can make these brakes really work this time. Brakes are going to be a bit of an issue. I can't get fluid out of 3 of the 4 tires. Looks like the lines are all clogged. So I really have to go through those one by one and clean them up. But I got fluid out of 1 tire, and it feels like it might be dragging slightly when I press the pedal. So that's brakes. So we're calling that done. And I'm going to install shiny new mufflers, because wow, this thing's loud. I have another purpose for these. See that perforated core? I'm going to mount these at an angle so the exhaust comes through and goes straight at that perforated core. That's actually going to act like a spark arrestor, so any sparks that go through are going to get trapped in that core instead of going all the way out. Because where I'm going to be driving this thing, it's going to be all dry all the time. So let's pop these things on. Shiny. I didn't get as much done today as I wanted to. Actually, the whole morning was spent doing a different project you'll see in another video. That's a different story. But I did finish up what I needed to test this thing out. I got brakes. By brakes, I should say brake, because that tire seems to be the only one doing anything, and not that much. But there is a brake, which means I can slow down. Also, got a complete exhaust system on, which means I welded mufflers to the end of the headers and pointed them out the side of the vehicle. So that's done. I'm ready to drive this thing. Problem is, there's no daylight left outside. So that's gonna have to wait till tomorrow. I swear the days are getting shorter if it wasn't for the fact that days are getting longer. But anyway, tomorrow, we're driving this thing. I don't even think I'm gonna try it out in the yard here. I think I'm going to load it on a trailer, haul it somewhere out in the open desert, and try it there. Because it'll either be really good or a complete failure. I'm going to bring my winch so I can load it back on the trailer afterwards. These tires are leaking so badly you can see where the dust is being blown out of the leaks. That might be a problem for holding air. Yeah, let's just ignore that for now. And we're done driving. That last launch took the tire right off the rim. And I didn't bring an air compressor. Well, that was a lot of fun. That tire that came off the rim was actually spinning inside the tire. So that slowed me down a little bit. I thought the clutch was slipping or something went out, but it was actually the rim spinning inside the tire. But that's it for this video. There's more to do. I got to fix that rim for sure. Probably put a floor in it. Maybe fix the brakes. You know, odds and ends like that. But this thing's a lot of fun to drive. And I had a lot of fun building it. So even though it's completely useless, it's a win. I hope you guys are having fun too, and we'll see you next time.